Lesson 2-2, linear equations. First of all, you have to be able to tell the difference between a linear equation and a nonlinear equation. Linear equations only involve the operations addition, subtraction, or the multiplication of numbers and variables. Nonlinear equations, on the other hand, have something that sticks out like a power, a square root, absolute value bars, or maybe variables that are multiplied together, or the division of variables. Those are nonlinear equations. Example 1, state whether each function is a linear function and explain. In letter A, we have f of x equals 10 minus 5x. This function is linear, meaning if you graph it, the graph is a straight line. We've got a linear function, and how can I tell? Well, there's only subtraction and then 5 times x. There's no power, square roots, or variables multiplied together. In letter B, we've got g of x equals x to the 4th minus 5. That power of 4 there tells me that the graph of this function is nonlinear. And in letter C, we've got a function in 2 variables, x and y, so h of xy equals 2xy. X and y are being multiplied together, and you can't have that in a linear function. So this one is also nonlinear because of the variables being multiplied together. Example 2, the linear function p of d equals 62.5d plus 2,117 can be used to find the pressure in pounds per square feet, d feet below the surface of the water. Find the pressure at a depth of 350 feet. Well, they're telling you that the value of d is 350. So we're going to plug that into our function. P of 350 is equal to 62.5 times 350 plus 2,117. And if you calculate that, you get an answer of 23,992 pounds per square feet. Okay, that's the pressure of the water 350 feet below the surface. Now the term 2,117 in the function represents the atmospheric pressure at the surface of the water. How many times as great is the pressure at a depth of 350 feet as the pressure at the surface? Well, to figure out how many times as great the pressure is at 350, we need to divide our answer, 23,992, by the pressure at the surface, 2,117. So go ahead and calculate that, and we get an answer of approximately 11.33. Okay, so that means that the pressure at that depth is more than 11 times greater than the pressure at the surface. Next, standard form of a linear equation. Any linear equation can be converted into the form a times x plus b times y equals c. This is what we mean by standard form of a linear equation. You want the x and the y values on the left side of your equation and then some constant c on the other side. Now there's 3 key things to remember about standard form. A, b, and c have to be integers, meaning that they're not fractions or decimals. The greatest common factor of a, b, and c is 1. And a, the first number, has to be positive. The coefficient of x has to be positive. So let's try rewriting these equations in standard form and then identifying a, b, and c. In this example, we have 3x minus 6y minus 9 equals 0. Well, the first thing that you want to do is get x and y on the left side of the equation and then any other constants moved over to the right. So I'm going to start by adding 9 on both sides. So now we have 3x minus 6y equals 9. And you can see that a, b, and c are integers here. However, 3, 6, and 9 have a common factor of 3, and I want A, B, and C to have a common factor of 1. So to get rid of that, I'm going to divide both sides of my equation by 3, because 3 is the common factor between 3, 6, and 9. Okay, so dividing by 3, 3x over 3 gives me 1x, minus 6y over 3 gives me 2y, equals 9 over 3 gives me 3. And now my equation is in standard form. The value of A is 1, because I have 1x. The value of B is negative 2, because there's a minus sign in front of the 2y. And the value of C is 3. A, B, and C are integers. The greatest common factor is now 1, and A is positive, so we've got it in standard form. Let's try this one. Negative 3/5 x equals 3y minus 2. Okay, now there's a couple things I'm going to have to do here. The first thing I want to do is position y so that it's on the left side with my x term. So to do that, to move 3y over to the other side of the equation, I have to subtract 3y. Because it's a positive 3y, I need to do the opposite and minus 3y on each side. So these cancel out, and now I want to rewrite it so that the x is first, negative 3/5 x minus 3y, and now it equals negative 2. Okay, so I've kind of set myself up to identify A, B, and C, but I have some issues, and the first one is this first term here is a fraction and I can't have fractions. My other concern is that A is negative, and in standard form, A has to be positive. The number with x has to be positive. So I need to do a couple things here. I need to cancel out the negative sign, and I need to cancel out this fraction. And because there's a negative sign here and I'm dividing by 5 in this fraction, the opposite would be to take the entire equation and multiply it by negative 5. And I'll just put the whole thing in parentheses and put a negative 5 out in front. Now, because I'm multiplying everything in the equation by the same number, I'm not really changing the value of any of the variables here. Okay, so multiplying this here, the negative 5 cancels out with this negative sign and the dividing by 5. And so what I'm left with is just 3x, because the 5's and the negative signs are canceling each other out. Now I'm going to take negative 5 times negative 3y using the distributive property, and I get positive 15y. Okay, and that equals negative 5 times negative 2, which is 10. Okay, so now let's look. I've got 3x plus 15y equals 10. A is 3, B is 15, C is 10. They're all integers. A is positive, and the greatest common factor is 1. There's nothing that can divide into all three of these numbers. So we've got it in standard form. Again, A is 3, B is 15, and C is 10. Okay, so you do need to manipulate your equations so that you've got standard form satisfied. Those 3 bullet points I had on that slide. All right, moving on to the last idea, x and y intercepts. Finding the x and y intercepts is a really easy way to graph a line because you only need 2 points to form a line. So the x-intercept is the point where the line crosses the x-axis, and the y-intercept is the point where the graph crosses the y-axis. You can see here that I've got an example of a line with an x-intercept of -4 and a y-intercept of +6. Now to find the x-intercept, what you can do is plug in 0 for y and solve the equation. And if you want to find the y-intercept, you're going to plug in 0 for x and solve the equation. Let me show you how. In this example, we want to find the x and y-intercept to graph the equation 3x minus 4y plus 12 equals 0. Now, the first thing that you want to do, just because it's going to make your work easier for you, is you want to put the equation in standard form. Okay, so what I need to do to get this equation in standard form is move the constant 12 to the other side of the equation. Okay, so here's the original equation. I'm going to subtract 12 on each side to put the equation in standard form. Okay, so 3x minus 4y equals negative 12. Okay, now it's in standard form. Okay, now that I've got it in standard form, I'm going to find the x and y intercepts. So to get the x-intercept, we are going to plug in 0 for the y value and then solve the equation. Here's how it works. 3x minus 4 times 0, 0 is my y value, equals negative 12. What always happens when you do this is that the term with the y ends up disappearing because 4 times 0 is nothing, and so you're really just solving 3x equals negative 12. Divide each side by 3, and the x-intercept is negative 4. Now, why does plugging 0 in for y work? Well, if you think about it, if I want to find the point where I'm crossing the x-axis, the y value's got to be 0. And so that's why we're plugging in 0 for y. So my x-intercept is at the point negative 4, 0. Over here on the graph, it's right there. Okay, now let's do the same thing, but for the x or for the y-intercept. To find the y-intercept, you're going to plug in x equals 0 into the original equation. So I'm going to take 3 times 0 minus 4y equals negative 12. This is going to give me the y value for the y-intercept. 3 times 0 is nothing, and so you can see that you're just solving negative 4y equals negative 12. Divide both sides by negative 4, and y equals positive 3. Again, this works because at the y-intercept where we're crossing the y-axis, the x value has to be 0, and now we just figured out that the y value is 3. Okay, so my y-intercept, when I go to graph it, is at 0, 3, right here. You should be getting 2 different points, one on the x-axis, one on the y-axis, and then you can connect them for your line. Okay, this line goes on forever, but all we needed was 2 points to graph it. All right, now I'd like you to check for understanding with these 2 problems. In number 1, you're going to rewrite in standard form, and in number 2, find x and y intercepts and graph the equation.